page 16. Okay, we're going to mostly go through this theorem called conjugate root theorem today. Conjugate. Do you remember the word conjugate from last chapter? Not really, huh? Okay, how about a plus bi has a conjugate? A plus bi has a conjugate. What is the conjugate of a plus bi? A minus bi. Okay, so conjugate means that you switch the sign in the middle. Okay, so we have this conjugate root. Very easy. It just says if you have two kinds of roots, one of them look like this, a plus square root b, or you have this other root that looks like a plus bi, they have to have a conjugate. So if you see an a plus square root b in the root, then there must be an a minus square root b. If you see an a plus bi in a root, then you must also have an a minus bi. So they have to come in pairs. Only the square root and the i's have these conjugates. All the other ones don't have conjugates. Okay, let's take a look. A quartic polynomial, degree of 4, p has rational coefficients. What does rational mean? No. We just did the rational root theorem. Fraction. So fraction, something you can put into fraction. Coefficients. What does coefficient mean? Number in front of the x. So they're telling us that this polynomial has coefficients that are fraction or integers, something like that. If square root 2 and 1 plus I are roots of p of x equals 0, so basically these are roots that make the polynomial 0, what are the other roots? Okay, if x is equal to square root 2 and x is equal to 1 plus I. If x is equal to square root 2, what must also be another root? Negative square root 2. The conjugate root theorem says if you have a square root, they have to come in pairs. If you have an x that is 1 plus I, what must also be a root?
1 minus I.
Good. All right. And then we got to multiply it out to find a polynomial function, but we'll do that in a second. Let's try another one. A third degree polynomial function has the rational coefficients with roots negative 4 and 2i. What is the polynomial function? Okay, we know that it's negative 4 and 2i. What other root must there be? Okay, talk to your partner. You guys are all kind of not sure. Talk to your partner. What other root must you have? Remember your conjugate root theorem. All right. Raise your hand if you can give me one. Yes. Oh, 4. Is 4 it? No. Why not? 4, you're thinking conjugate of negative 4, right? The conjugate root theorem only applies to what kind of numbers? Square root and i's. So negative 4 is not a square root, it's not an I, there's nothing in there, it's just an integer, so no, there's no 4. Okay, which other one must be in there? Yeah? Negative 2i. All right, now we are going to find the polynomial function, which a lot of you missed this on the quiz. Polynomial function means we are going to multiply a lot of factors together. Okay, so if if the root is minus 4, what is the factor? Factor means you start with x and then you blah, blah, blah. X plus 4. You always subtract the root. So x minus 4, so x plus 4. Yeah, no, Daniel cannot. Okay, minus 4, so x plus 4. All right. Okay, if the root is x equals 2i, what must be the factor? Minus 2i. If the if the root is minus 2i, what's the factor? Plus 2i. Okay, now we're gonna multiply them all together. Yeah, it's kind of long. If you start from here, it will not be a wise choice because you're gonna get a bunch of i's that's gonna cancel out later. So here's what you're gonna do. You're gonna do these two together. This is a minus b times a plus b. A minus b times a plus b is what? You're too fast. Just a minus b times a plus b. A squared minus b squared. Yes? Okay. Like this section is nodding their head, but no. Can I remember this? Okay. A minus b times a plus b is a squared minus b squared. All right. This is going to be a squared minus b squared. Okay, 2i squared is going to be 4i squared. I squared is what?
Negative 1.
Negative 1. So negative 1 times 4 is, times negative 4 is plus 4. So x squared plus 4. And then we still have the x plus 4 in the front. There's no more shortcuts. You just have to FOIL. So go ahead and FOIL and write the answer in polynomial form. The answer is x cubed plus 4x squared plus 4x plus 16. All right. Let's try another one. So this time, you are going to write the roots, and then we'll do the polynomial together. Okay, so you are given x equals 13i and x equals 5 plus 10i. Go ahead and find the other two missing roots. All right, Andy, give me the other root, one of the other roots. 13i. Well, 13i is already in the problem. Yeah, minus 13i. Okay, and let's see. Brady, give me another one.
5 minus 10i.
5 minus 10i. Okay. All right. We are going to multiply it all together, but this one's too hard for us right now. We're going to go back to this first one that we skipped. Okay, let's go ahead and write them in factor form for now. If the root is square root 2, what is the factor? If the root is square root 2, what's the factor form? Oh no. Okay, all right. Here's what you do. Every time you see a root, you always just subtract to get to the factored form. All right, try one more time. If the root is square root 2, what is the factored form? Okay, all right, we need more audience here. Okay, let's pick on someone. Nathan, if the root is negative square root 2, what is the factored form? Yes, x plus root 2. All right, let's do the challenge one. If the root is 1 plus I. Okay, let's have you talk to your partner, so at least you have someone else to think. If the root is 1 plus I, what is the factor form? Talk to your partner. If the root is 1 plus I, what is the factored? All right, let's see. If the root is 1 plus I, CJ and Sam, what do you guys think? Give me something. Guess. Better than no guess. It's better. Don't. Okay. So a lot of times people are afraid to give out answer because they're like, well, it's wrong. Okay, it's better than don't think at all. Just if you just sit here and for me to give you the right answer all the time, you will not think, and then eventually you will not get better. It's better to think wrong and then get corrected than just wait, because then I'm doing all the work. All right, give me a guess. Something. Nothing. Okay, speechless. Okay, Josh and Terry. Oh, okay. All right. Give me a thumbs up if you got this, and then this is pretty easy. Sideways, I need more help. Downwards, like I don't know what's going on at all. All right. Everybody take out your whiteboard. Let's go ahead and practice, because this is not good.
I never learned that hard.
All right, let's do this. Okay, so I'm gonna do it on another one. Okay, let's go back to this question. Now we can write the factored form. Okay, so we have a root that is 1 plus I. Then what is the factored form? Oh, okay. All right. Let's have everybody come back to the notes first.
What happened?
Yeah, I'm trying to figure out what's happening. Okay, so the root is 1 plus I. What is the factored form?
X minus 1 minus I.
Good. Okay, if the root is 1 plus I, 1 minus I, then the factored form is?
X minus 1 plus I.
Good. Okay, now we need to multiply these 4 roots together, and it's going to be horrible. So I'm going to show you a shortcut. Or actually, before I show you a shortcut, I'm going to tell you what to do. The worst thing you can do is 2 at a time in this direction. And then once you get this, you go 1, 2, 3, 1, 2, 3. And then now you have like 9 terms, and then you multiply it all together, and then you're hoping things cancel. It's just crazy. Don't do it this way. You have to be very, very precise to not get it wrong. Okay, so what you want to do is 2 at a time. These 2 and these 2. Because they're conjugate of each other, so things should cancel. All right. This one we already know. It's a squared plus, a minus b times a plus b. So it's going to be a squared minus b squared. Square root 2 squared is, 2. Okay, x squared minus 2. This one, if you FOIL, it would be 9 times. Okay? That would be horrible. So don't do it this way. Actually, I was doing this way until someone 2 years ago in my class said, Miss Young, I found an easy way to do this. I was like, oh, you're so smart. Okay, teach me your way. All right, so she said that these 2 repeat and these 2 repeat. So she said, why don't you just think of this as a minus b and a plus b? I said, wow, you're so smart. That's true. So this is x minus 1 squared minus I squared. A squared minus b squared. Yeah, you can do a squared minus b squared on anything as long as they fit that form. Now, in order to make this this thing faster, you just have to know how to square x minus 1. X minus 1 squared is what?
1x squared plus 1.
Oh, this is where you don't listen to Satan. Okay.
X squared plus 2x.
Minus 2x plus 1. Okay, so square the first term, square the last term, take the product, and double. So square the first term, square the last term, take the product is negative x, and double, so minus 2x. Okay, or just remember this is always how it's going to look. I squared is what?
Negative 1.
Negative 1 times that negative 1 in front was a 1. Okay, x squared minus 2 times x squared minus 2x plus 2. Okay, now you have to FOIL. So there's no way around that last step, which is you do have to FOIL. At least one less thing to FOIL, I guess. Go ahead and FOIL and let me know when you have the answer. The answer is x to the 4th minus 2x cubed plus 4x minus 4. All right? Okay, let's try another one. So you already came up with these roots. Now go ahead and write in factored form. So let's try this together. Let's see. Daniel, if the root is 13i, what is the factor?
X minus 15.
Yes. All right. Mark, if the root is minus 13i, what is the factor?
X plus 13.
Evan, if the root is 5 plus 10i, what's the factor? Yes. And last one, Trey. If the root is 5 minus 10i, what is the factor?
X minus 5 plus 10.
Yes. Okay. Now here's what you're going to do. You're going to split up the work with your partner. So one person does these two, which is the hard one. You have to thank them later for taking the hard one. And then one of you take the easy one. Okay, and then once you have that, multiply it together. For the sake of time, I'm going to help you guys out. So this part is x squared plus 169. This part is x squared minus 10x plus 125. And you got to just FOIL that and combine like terms and all that stuff. Okay, so that's going to be x to the 4th minus 10x cubed plus 294x squared minus 1690x plus 21125. Pretty crazy. If you got it, good job. Very nice. All right. The last part we're going to go through is another theorem by René Descartes. That guy on the wall, the window over there, René Descartes. So he came up with this theorem. So a lot of people have the ways of guessing what are the roots because it's just kind of hard. So he came up with this theorem that can guess what kind of roots will be in the polynomial. Do you guys finish copying? Almost. He is very smart. Okay, so his rule of signs. He says the number of positive real roots of the polynomial is either equal to the number of sign changes between consecutive coefficients of p or less than that by even number. So I'll show you what that means. The number, and then the second one, the number of negative real roots of p of negative x is either equal to the number of sign changes between consecutive coefficients of p of x or is less than that by even number. Okay, so Basically, he's saying there are some ways of guessing what kind of roots there may be. For example, if you look at this thing. Are you okay?
Yeah.
Okay, so this is the polynomial, and we're going to guess how many positive real roots and how many negative real roots there may be. So he says, first, if you want to guess the positive real roots, you just put the polynomial in there. So x cubed minus x squared plus 1. Then he says, check the sign changes. So we're just going to look at the sign. What is the sign in front of x cubed? Positive. What is the sign in front of negative x squared? Negative. And then what's the sign in front of 1? Positive. So how many times did the sign change? Twice. Once, 2 times. So he is saying the possible number of positive roots is 2. Or less than that by even numbers. So basically subtract 2. 2 or 0. So there might be 2 positive or no positive. All right. Now we want to check negative real roots. So what you're going to do is you're going to take the same polynomial, but this time you're going to put negative x in there. Okay, so that means every time you see an x, you need to put a negative x. Negative x cubed is what? Negative x cubed. Negative x squared is what? X squared, and then there's a negative in the front, so minus x squared plus 1. Okay, what is the sign on this polynomial? Negative, negative, positive. How many times did the sign change? Yeah. No, negative x squared is positive x squared. Yeah. Just do it in order. Okay, how many times? Are you guys okay? Okay, please focus. So how many times did the sign change? Once. So there's going to be 1 negative root. There is 1 negative root. Okay, so the theorem is less than that by an even number, but we cannot subtract an even number. If we do, we're going to get negative. So, all right, go ahead and try it at home.